Hello everyone, welcome to the next session. The sign convention, mirror formula and magnification are the topics that we will look into in this session. But make sure that you watch the previous videos so that you will understand more about sign convention, magnification and mirror formula. So this is a part of a continuation series. Okay, so now we will start with sign convention. So what can you see from this 4 parts? Is it like a graph sheet where you have 4 quadrants? Yes. So this is your first quadrant. So what will be the first quadrant? Everything will be positive. Good. This x will be negative but y will be positive. Here both negative. X and y will be negative. Here x will be positive, y will be negative. Okay, so with that notation, we will start with our sign convention in the using the mirrors. So this will be negative and y will be negative here. Okay, so I have taken a concave mirror for my reference now. So we'll start with the image distance. Image distance, we'll represent it as u. Sorry, the object distance will be represented as u. Object distance is u. So we'll keep the object always in front of the mirror. Good. So whenever I keep the object in front of the mirror, then my sign will be, the distance will be measured in x-axis. So my sign will be always negative. Good. So u, the object distance, will always be negative. No matter where you keep the object, you will keep object where in front of the mirror always. So the object distance will be always negative. Good. Now, what about the focal length? Will that be also negative? Because the focal length, we say that it is here, right, in front of the mirror, the focus. So this will be the focal length. So the focal length will also be negative, but it will be negative for what? For which mirror? Focal length will be negative for concave mirror. Good. It will be negative for concave mirrors. What is about the convex mirror then? It will be positive. Very good. So focal length will be positive for convex mirrors because I take my focal length, center of curvature in the other side. Okay, for convex mirrors. Good. So we have finished object distance, which is always negative. Focal length, which is negative for concave and positive for convex mirrors. Now we will move on to image distance. Okay. Now I say my image is formed here. Okay. My image is formed here. That is, image distance is v. Image distance is v. So my image distance is negative for real and inverted images. Good. It will be negative for real and inverted images. So it will be positive for virtual and erect. Very good. Virtual and erect images. So my image distance will be negative for real and inverted and positive for virtual and erect. So this will be the case for real and inverted will be only for the concave mirror. For convex mirror, it will be only for virtual and erect. So whenever it is forming this side, so all the 5 cases in your concave mirror will be, the image distance will be negative. Okay. Whenever it is this side, it is virtual and erect, positive. Okay. Now, this is my What is it? Yes, height of the object. So, height of the object is always positive, no matter which mirror you are using. Okay, height of the object will always be positive. So, I can also write it as object height, right? Object height. Okay. So, what about my object image height? Image height will have two cases, right? Height of the image, it will have two cases. What are the two cases? It will be negative for real and inverted images and positive for virtual and erect images. Very good. Okay. So, we have seen object distance u, which is always negative, no matter which mirror you are using. Then the focal length, it is negative for concave mirror and positive for convex mirrors. Then object height, it is always positive. Image height, it will be negative for real and inverted images and positive for virtual and erect images. And image distance v will be negative for real and inverted and positive for virtual and erect images. Okay. So, I hope you are clear with sign convention. Now, we will move on to mirror formula. Mirror formula and magnification. Mirror formula is very simple, which is the relation between the focal length, your image distance v and your object distance u. So, f is focal length, your v will be the image distance, and u will be the object distance. It is 1 by u, 1 by f is equal to 1 by v plus 1 by u. 1 by v, f is equal to 1 by v plus 1 by u will be your mirror formula. You don't have any derivation for this in this class, but in the higher classes you will have to derive this formula. Now we will move on to magnification. Do you know what is magnification? When you just zoom in like this, zoom in and see. So this will be your magnified image, right? I have magnified the writings here. So this magnification also has a formula, and we use this magnification in terms of diminished, enlarged, point sized, highly enlarged, all these things in our cases that we studied in image formation. Okay, so this magnification has a formula. So magnification m is the ratio of height of the image to the height of the object, ratio of height of the image to the height of the object. But then there is a relation between this height of the image and height of the object with your object distance and image distance, that is your u and v. Okay. So m magnification hi by ho can also be written as minus v by u, where v and u are your image and object distance. Okay. And this magnification, does this have a unit? Yes or no? It has no unit. Good. So it has no unit. Your focal length will be of the unit centimeter, meter, whatever we are using for the image distance and object distance. So this will be the relation, but the magnification will be negative for good real and inverted images. It will be negative for real and inverted images. So it will be positive for virtual and erect images. Yeah? Magnification is negative for real and inverted images and positive for virtual and erect images. So with sign convention, mirror formula and magnification, we will now see some of the problems that is usually asked. Okay. So the question 1 says a concave mirror produces 10 centimeter long real image of an object height 2 centimeter. What is the magnification produced? So what is given first? Your object height is given. So your object height is always positive 2 centimeter plus 2 centimeter. And your image height is also given hi, but this is a real image, so your image will be positive or negative image height. Yes, it is negative. Good. So it is 10 centimeter. We have to find out the magnification. So m is equal to hi by ho. So minus 10 by 2, which is minus 5. So magnification here is minus 5. Minus here represents that it is a real image, and the magnified, how much the object has been magnified? It is been magnified 5 times. Okay, it is been enlarged. Okay, yeah. So the next question, a erect image 3 times the size of the object is obtained with a concave mirror of radius of curvature 36 centimeter. What is the position of the object? So here R is given. R is 36 centimeter, but this is a concave mirror. So it will be minus 36 centimeter. So if you have R, what can you find out? Good, you can find out F. So R is 2F. So F is equal to R by 2. So it will be minus 36 divided by 2, which is minus 18 centimeter. So your F is nothing but your minus 18 centimeter. You have found out your F. You have your focal length. Fine. What is the other things given? An erect image. Erect image meaning it is a virtual and erect image. So your height of the image will be positive or negative? Yes, it will be positive. So an erect image is 3 times the size of the object. So object height will be again positive. Good. So it says the erect image is 3 times the height of the object. So I can write hi divided by ho is equal to 3. Can I write this hi by ho as minus v by u equals 3? Can I write that with the relation? Yes, good. So I can also write minus v is equal to 3u and v is equal to minus 3u, right? With the basic algebra. Yes? Okay. So now v is also in terms of u. But now again we move on to the mirror formula. We have to find position of object. So you have to find u. So with mirror formula 1 by f is equal to 1 by v plus 1 by u. We will now substitute minus 3u for v. So 1 by f is equal to minus 1 by 3u plus u. When you take LCM, it will be 3u will be the LCM, minus 1 plus 3. It will be 2u, 2 by 3u. So your f will be 3u by 2. We have to find u, not the f. So my u I can write it as 2f by 3. So what is my f value? 2 into minus 18, very good, divided by 3. I can cancel and my u will be minus 12 centimeter. I think centimeter is the one which we were being, yeah. So radius of curvature says it is centimeter. So I have used centimeter throughout my problem. Okay. Okay. With this, we'll move to the next one. An object 4 centimeter in size, is placed at a distance 25 centimeter from a concave mirror of focal length 15 centimeter. Find the position, height, position, nature of the image and height of the image. So, object size is given, HO, it is plus 4 centimeter and it is placed at a distance of 25 centimeter. So, it is U is equal to minus 25 centimeter. Your F is minus 15 centimeter. Good. So, we have to find V and HI and then the nature. Whether it is real, diminished, all those things we have to find out. Okay. So, with F and U, we can find out V with mirror formula. Good. So, 1 by F is equal to 1 by V plus 1 by U. So, 1 by minus 15 equal to 1 by V minus 1 by 25. I want only V, so I take the minus 25 this side. I will get minus 15 plus 1 by 25. The LCM between 15 and 25 will be 75. So, if I take 75 as my LCM, this will be minus 15 5s are is 75 plus 25 3s are is 75. So, it will be minus 2 by 75. My V will be 75 minus 75 minus 75 by 2, which is also minus 37.5 centimeter. Yes or no? Yeah? Minus 37.5 centimeter. Now, then I have HO, V, U, I can find HI. So, HI by HO is equal to minus V by U. So, HI is equal to minus V into HO by U. Now, just substitute all the values in this equation. So, HI will be minus into minus of minus 75 by 2 into HO, that is 4, divided by minus 25. So, this minus and this minus gets cancelled. Yeah. So, my HI will be minus 75 into 4 divided by 2 into 25, reciprocal. 25, if you reciprocal, it will be 1 by 25. So, I have just written it as 2 into 25. It will be in the denominator. So, 25 3s are 75, done. And 2 1s are 2 2s are 4, that is also done. So, my image height will be minus 6 centimeter. So, I have found out my V, my HI, the image height, and now I have to find out nature. So, what can I say for the nature? My image distance is again negative, height of the image is also negative. So, good. My nature of the image will be real and inverted because the height is also negative and my image distance is also negative. So, real and inverted. Then, what else can I say? Whether it is enlarged or diminished, what else? It should be enlarged. See, there is 4 centimeter. 4 centimeter is the height of the object, but 6 centimeter is the height of the image. So, it is enlarged. Yeah, because height of the object is 4 centimeter and height of the image is 6 centimeter. Yes. So, can you find out where the object is placed? Can you find out which case are we talking about in the concave mirror? Your focal length is minus 15. So, your center of curvature should be at 30. Okay, obviously minus 30. So, So 30 and 15. So middle is the 25. So your object is the object is placed between C and F, and the image formed is beyond C, because your C is center of curvature is at minus 30 centimeter. Your image is formed at minus 37.5 centimeter, which is again beyond C, right? So the object is placed between C and F, and the image we have got is beyond C. Okay. So with this, we will wrap up this session on the sign convention, mirror formula, and magnification. These are the application of those formulas that we studied. So next, we are finishing the reflection part here. We will be moving on to the refraction in the next session. Hope you find it useful. We will meet you in the next session. Thank you.